Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 7 Linear Programming, Long Question Example 1. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. Pak Zain has a plot of land on which he wants to plant cabbages and tomatoes. The cost of planting cabbages and tomatoes are 2,400 ringgit per kilometer square and 1,600 ringgit per kilometer square respectively. Pak Zain's plantation plan is subjected to the following constraints. So as you can see here, we have three constraints. So let me read the first one. The area of the land he owns is 10 kilometers square. Okay, for the second constraint, the capital Pak Zain has is only 19,200 ringgit. For the constraint 3, the area planted with tomatoes is not more than 2 times the area planted with cabbages. Pak Zain allocates X kilometer square for planting cabbages and Y kilometer square for planting tomatoes. Okay, so for the question part A, write 3 inequalities apart from X more than equals to 0 and Y more than equals to 0 which satisfy the above constraint. Okay, in this case, the following 3 constraints here. Okay, continue to read the question part B. Using a suitable scale, draw the graph of the 3 inequalities. Hence, construct and shade the feasible region R that satisfies the given constraints. Okay, usually in a linear programming question, they will give you the scale, but in this question, they did not give you the scale. So you need to figure out with the suitable scale, guys. Okay. So from here, continue to read the question part C. Based on your graph, answer the following questions. Okay. For the question C, part 1, Pak Zain obtains a profit of 280 ringgit per kilometer square for cabbages and a profit of 200 ringgit per kilometer square for tomatoes. Find the maximum total profit Pak Zain can obtain. For the question C, part 2, if the area planted with tomatoes is 4 km square, find the range of values of the area planted with cabbages. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Let us begin our discussion for the question part A. Whenever we want to solve a linear programming question, the first step what we need to do is we need to identify the constraints and write them in terms of mathematical form. Okay, in this case, the 3 constraint is already given to us. So what we need to do now, we need to convert this statement into mathematical form. Okay, so from here, let me write the step here. Okay, so from here, the first mathematical form we can come up is, so please wait. Let me underline a very important statement. So can you see here? They're actually emphasizing X for cabbages and Y for tomatoes. Okay, so this is very important information. So if I were you, I would underline this in the first place. Okay. Okay. So this is a very important point. Okay, let me write in the working here. So X is representing cabbage and Y represent tomatoes. Okay, so from here, let us start to write down the constraint into the mathematical form by begin with the constraint 1. Okay, the constraint 1, okay, it mentioned here the area of the land he owns is 10 km square. Okay, in this case, he stands for Pak Zain. Okay, in this case, okay, so from here, the land he owns is 10 kilometers square. Okay, within this land he wanted to plant cabbages and tomatoes. So from here, this total number of cabbages and tomatoes must be within the 10 kilometers square. So from here, if you want to write this constraint in terms of mathematical form, it will be x plus y should be less than equals to 10. Okay, so it is makes sense, guys. Okay, no matter how much cabbages and tomatoes you plant in, it should not exceed 10 kilometers square. Okay, it should be within the 10 kilometers square or equals to 10 kilometers square. Okay, so I hope I made this clear. So for the constraint 1, so let us proceed to the constraint 2. Okay, so for the constraint 2, it mentioned here the capital Pak Zain has is only 19,200 ringgit. Okay, so let us take a look at the cost of planting cabbages and tomatoes. Okay, it mentioned here 2,400 ringgit per kilometer square and 1,600 ringgit per kilometer square respectively. So this is also an important information, so please underline this as well, guys. Okay, so cabbages is actually 2,400. Okay, so for the tomatoes, let me use a different color. Okay, and tomatoes is 1,600. Please wait. Okay, so all right, so this is important information. Okay, so the cost we know already. So the total capital allocated for Pak Zain is only 19,200. Okay, so from here 2,400 x plus with 1,600 y should be within or equal to 19,200. So from here we can simplify this equation. Okay, so how are you going to simplify this equation? So we divide the whole equation by 800. Okay, so from here when you divide the whole equation by 800, so from here you get 3x plus 2y should be less than equals to 24. Okay, there is a reason why we are doing the simplification. Okay, because it will be easier for us to plot the graph in our upcoming steps, guys. Okay, so our constraint 2 is literally done. Okay, let us proceed to the constraint 3. Okay, so from here the constraint 3, the area planted with tomatoes is not more than 2 times the area planted with cabbages. Okay, so we have already clear here, tomatoes in this case is y. Okay, cabbages is actually x. So from here area planted with tomatoes is not more than 2 times. Okay, not more than 2 times means it should be less than equals to 2x. Okay, in this case your tomato is y and your cabbage is x. So it's literally fulfilling this condition where the area planted with tomatoes is not more than 2 times. Okay, it should be less than equal. Okay, so this is the answer, guys. Okay, let me underline the constraints. So this is your first constraint, this is your second one, and this is your third constraint. Okay, this step is actually very important, guys. Okay, the reason is if you got mistake in either one of these constraints, your whole working will get affected. Okay, you will lose a lot of marks in this case. So make sure that your step 1 is very clear. Alright, guys, so I hope I made myself clear about this. So from here, let us proceed our discussion for the question part B, where we require to draw the graph of 3 inequalities. Okay, based on these 3 constraints. Okay, and then we need to construct and shade the feasible region R that satisfy the given constraint. Okay, that will be our step 2 over here. So let me write the following step here. By the way, for the question part B, I've already drawn the graph and shaped the region R for you. So let me open the graph paper. So this is how your graph should looks like. Okay. So as you can see here, this is the title of the graph where it mentioned linear programming of Park Zain's land. Okay. And this is the y-axis. Okay, y-axis representing the tomatoes. Okay, x-axis is representing the cabbages. Okay. And these are the three respective straight lines, okay, that we have plotted. So in case if you're wondering why there's a hidden line, I mean there is a dotted line over here, so please hold on, I'm going to explain to you. And the same thing for the max point. Okay, I will explain to you at the end of the question. Okay, so from here let us begin with the x plus y equals to 10. So to plot this straight line is very simple. You just use the intercepts, okay, the 2 points. So from here, this is your y-intercept. Okay, when your x equals to 0, so it will be y equals to 10. So this is your first point. Okay, and the same thing for the x-intercept. So when your y equals to 0, your x will be 10. So this 2 point, and then from there you make a straight line. Okay, so and then now proceed with the second straight line. 3x plus 2y equals to 24. Okay, similar thing. Okay, I choose the intercept. Okay, so for the y-intercept, so you set your x equals to 0. So 2y equals to 24. So from here you get your y equals to 12. Okay, so let me erase this. Okay, so you get your y equals to 12. Okay, so and then for the x-intercept, you set your y equals to 0. So from here 3x is equals to 24. So to get your x, what you do, 24 you divide by 3. So that's how you get the 8 here. So you have 2 points. So from there you can plot the second straight line. Okay, so pretty straightforward. So from now we can proceed to the third straight line. So where you have y equals to 2x. Okay, so you choose any 2 points. So in this case you can choose the origin, okay, and the coordinate point 2, 4. So this 2 point is sufficient for us to plot the straight line y equals to 2x. So it's pretty straightforward over here. Okay, but then the working does not complete just like that. Okay, you need to shade the particular region, okay, since it involves inequality. Okay, so let us begin with x plus y equals to 10. Okay, what I will recommend for the student is don't immediately shade all the region, guys. Okay, instead what you do, you just make a small mark in your question paper. Okay, so in my explanation I have to mark it a bit bigger for the explanation, but in your examination you just make a small mark over here. Okay, if you make it too dark, it will be very difficult for you to erase. So that is why I'm telling you, make a small mark. Okay, so from here, so since it mentioned that x plus y should be less than equals to 10, so you should be shading the x plus y equals, I mean less than equals 10 in the lower region. Okay, not the upper part, you know, the lower region, guys. So you need to mark in every possible region over here. So you make a mark over here. Okay, you make a mark over here. Okay, and you make a mark over here. Okay, so that is for the x plus y less than equals to 10. So from here, let us proceed to the second inequality where 3x plus 2y less than equals to 24. Okay, so for this one, so since it's less than equals to 24, you should be shading at the down part. Okay, so from here you should mark this region. So you need to mark every possible region, guys. Even this small region also you need to take consider. Okay, this small region. Okay, this small region, I mean this region, this one. Okay, how about this one? Okay, this one you cannot mark, guys, because it's already outside the straight line, so you cannot mark this. Okay, So from here, okay, that is all for the second inequality. So let us proceed to the last one, where y should be less than equals to 2x. Okay, for y less than equals to 2x, you should be shading at the down part over here. So let us mark over here this region, okay, this region, okay, and then this region. Okay, so from here, let us close this and back to our black pen. Okay, so after you have made a mark, so you need to see which region has the most number of marks. So as you can see here, in this particular region, you have three colors over here. Okay, these three colors is representing three straight lines. Okay, so it's actually fulfilling this region. Okay, all the three constraints fulfilling this particular region. So now what you can do is you can proceed to shade this whole region over here, okay, which I've shown for you guys. Okay, start from here, and then there is a small polygon forming over here. Okay, so let me just make a shade over here. Okay, so you just make a shade over here. So this is how your inequality should looks like. Okay, so for the question part B, so I hope I made myself clear about this. So from here, let us proceed our discussion for the question part C. Okay, so this is for the question B. So question B, I hope you guys are clear about this. Okay, for the question part C, so question C part 1, it mentioned that Pak Zain obtains a profit of 280 ringgit per kilometer square for cabbage and a profit of 200 ringgit per kilometer square for tomatoes. So within this information, we're going to form a new equation for profit, where P is equals to 280x plus with 200y. Okay, let me box this equation. Okay, so for the next step, what you're going to do is we're going to assign a number for the P. So in order to assign a number for the P, you have two options. You can assign any number you want, or you can use the LCM method. So in this case, what I'm going to do is I'm going to assign a number where P is equals to 560. So if you don't know what number to assign, so be safe side, you just use the LCM method. Okay, so LCM method in this case will be 280. You just times with 200, and that value you substitute as your P. Okay, so this P is not a real number, guys. It's just an imaginary number. So from here, 280x plus with 200y equals to 560. Okay, so to simplify this equation, you divide the whole equation by 40. So from here you get 7x plus 5y, okay, is equals to 14. Okay, so I hope you guys are clear about this. So the reason why we are simplifying this is because it will be easier for us to plot the dotted line. But then in the calculation of profit, you cannot choose this equation, guys. You need to choose the original equation where P is equals to 280x plus with 200y. Okay, so let me open the graph paper now. So this is the equation, okay, where in this case the 7x plus 5y equals to 14, or also known as 280x plus 200y equals to 560. Okay, so from here, this is your y-intercept. Okay, in this case your y-intercept is actually equals to 2.8. okay, and this is your x-intercept, so where your x is actually equals to 2. So from here, what you need to do is, since we are required to find a maximum point, so if you're wondering where is the maximum point, so this is your maximum point. So what you need to do, okay, whenever you're solving the question, you need to use a ruler, okay, and you need to move it perpendicular. Okay, so this straight line, you need to move it perpendicular. So when you move it, the ruler slowly, and eventually when it hits the furthest point of the polygon, which under the shaded region, okay, it will eventually touch this maximum point, okay, where you have it 4 6. Okay, then you can ask me, so why not this point? Okay, it can be this point, but if you take a look here, in reality you cannot have a number of cabbage and tomatoes in decimal number. So the possible number you can have is this, where you have your number of cabbage is 4 and your number of tomatoes is 6. So that's why you have the maximum point of 4 6, guys. Okay, I hope I made myself clear about this. Okay, so from here we already identified the maximum point. So for this working, guys, in solving the question, so what you need to do, okay, I'm repeating again, you need to move the ruler perpendicular to this direction, okay, perpendicular to this direction, okay, until it hits the furthest point within the shaded region of the polygon. Okay, so I hope you guys are clear about this. So since we have identified the max point, so from here we can use this point to calculate our maximum profit. Okay, let us continue. So from the graph, so we get our maximum point is equals to, okay, it's actually 4 6, guys. Okay, let me just open it again, double check. Okay, it's actually 4 6, yeah, 4 6. So from here, to calculate the maximum profit, so for maximum profit, so from here P max will be equals to 280 times with 4, okay, plus with 200 times with 6. Okay, calculate this. So from here you get your maximum profit is equals to RM 2320. So this is your answer for the question C part 1. So let me underline this. Okay, so from here let us proceed our discussion for the question C part 2. Okay, in the question C part 2 they mentioned that if the area planted with tomatoes is 4 kilometers square, find the range of values of the area planted with cabbages. Okay, so tomatoes is actually representing the y-axis. So you need to find out when y equals to 4, so what are the possible x value that we can obtain from the graph. So let me open the graph paper again. Okay, so since it's a bit messy, so please give me some time for me to erase this. Okay, so let me erase this. Okay, I think now it's clear enough. As you can see, this is the y equals to 4. So from here what you do, you just mark a straight line from this end until this end, okay, and then you plot it down. But then you need to be really careful, guys. You cannot have a decimal number of x since you are dealing with a real life object. Okay, for example, you only can have 1 cabbage, 1 tomato, 2 cabbage, 2 tomato, okay, and so on. You cannot have a decimal number. So within this y equals to 4, so the minimum number you can achieve is x equals to 2, okay, and then the maximum number you can possibly achieve is actually x equals to 5. So this is actually 5. So if you wanted to exceed, yes, you can exceed, but you will end up by getting 5.2. Please wait for a second, guys. So you'll end up by getting 5.2 and 5.4. So this value will be actually representing 5.4. Okay, in reality you cannot have 5.4 cabbages, right? So it makes no sense. So you only can have x equals to 2 and x equals to 5. So this is your lowest and highest range respectively. So from here, okay, so for the question C part 2, when y equals to 4, so from here, this is your final answer, where your 2 less than equals to x less than equals to 5. Okay, so let me underline the solution for the question C part 2. Okay, So that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give it a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.